All right, we are right at the start time, 2 o'clock Eastern Standard Time, so we will begin. First off, good afternoon. I am Jason Thomas, Project Engineer with America Makes, and your host for today's America Makes TRX webinar series. A little background on the TRX webinar series before I introduce our speaker. As America Makes continues its mission to expand and accelerate the footprint of additive manufacturing and 3D printing, this medium called the America Makes Technical Review and Exchange webinar series was created. By creating this platform, it allows the additive manufacturing and 3D printing community to come together and share knowledge and experience with a broader community. If you or your team are interested in presenting during the TRX webinar series, there will be a link to complete the request form at the end of our series today, or you can contact the America Makes Membership Director, Tiffany Westbay, directly. A few important notes before we kick off the series. At the end of the presentation, there will be an opportunity for a brief question and answer section. If during the presentation you have a question, please submit it in the Q&A space on your WebEx screen, and we will ask it during the Q&A session. We will do our best to get to all the questions. Today's webinar is on additive manufacturing production, work order, and process management best practices. Without further ado, it is my pleasure to introduce Todd Wenzel from Blue Streak.
Well, thank you, Jason. We'll just get right into it. I want to mention as part of this that if you have some questions during this presentation, feel free to type them in right away. I don't have a problem answering those in the context of the presentation. So if you'd rather hold to the end, that's fine also. Just a quick item about me. I've been involved with designing software systems and architecting since about 1989. So you can do the math there. It gets longer every year, imagine that. And about Blue Streak, Bright AM. Blue Streak first came out 2006. Now, it was architected right from the beginning to be a browser-based application, which just means your browser is the interface to get to the application. Now, back in 2006, if you remember back then, it's pretty difficult to do an application in a browser. So we were kind of pushing the limits there. Fortunately, we picked the proper technology so that as time moved on, the browser became more and more important, and all of the various browsers from different software vendors all begin to merge instead of being very different. So there's a very good base sense of a set of functionality across all browsers, and so we're able to leverage that to provide a really nice user experience. And so that came out. It was initially we were targeting more service-based companies that are in the manufacturing supply chain. And so places like heat treaters and powder coaters and platers and testing labs, places that didn't necessarily build parts, but they took parts in from a customer, provided some service, returned them back. Because there's a big void in the market. ERP systems don't really work well in that type of an environment. So that's what Blue Streak was. That's the heritage. And about 3.5 years ago, we got into the additive manufacturing space. So obviously there you are producing parts. So there are some differences. But we were fairly early on in that environment and working with a very well-known company was actually doing additive manufacturing in the aerospace realm. So that's obviously the most strict environment to try to produce parts for. So we learned a lot during that process. So it's just a reminder, everybody, additive manufacturing, even though you hear a lot about it now, that's sort of the buzzword in manufacturing space. It's been around for a long time, at least the early 80s. But it's really only now sort of gotten gotten to a point where people are really looking at it, and the technology has been improving all along. And you can use it to build airplane parts and parts that go into your body. You're at a point where it's a mature, it's not fully mature, but it's still a very mature and usable technology. And as I mentioned earlier, aerospace arguably has the most stringent quality requirements out there, even more so than medical. Medical is accreditation, quality accreditation called Medicred, which is trying to basically emulate what NADCAP, which is the aerospace quality accreditation, is doing. So medical is behind aerospace. Aerospace has always been in the lead from a quality standpoint. And so this presentation, I'm not going to be really showing screens and all that, working you through an application. That's not what this is about. Just kind of giving some information, things that we've discovered while working in the additive manufacturing environment in aerospace, and improvements and changes and tweaks that we found needed to be made from standard MES and QMS. And MES is a manufacturing execution system. That's basically the tracking on the shop floor. And the QMS is quality management system. That's what Bright AM is. It's really those two pieces put together. And I'm just going to go over some of these things that we found that were interesting in the additive space. So basically, at a high level, what I want to go through is talk about build plate work order organization. So I'll talk more about that, but it's basically a way of managing work orders that are associated with the parts being printed in a way that you can kind of track them all together. Serialization is a big deal in the aerospace realm. Everything's got to be serialized. It's the same thing in medical. I mean, even companies that are printing shoes, they want to serialize things too. So basically, most companies end up wanting to serialize the parts that they're actually printing in whatever medium they're printing them in. So being able to have a serialization system where you can guarantee that you have unique serial numbers being applied to each part being printed is important. The tracking of realities out on the shop floor in an AM shop have a lot of similarities with a standard manufacturing shop, but there's some stark differences there too. So we'll kind of go through that. Non-conformances, that's another area in additive manufacturing where we found it's quite a bit different than standard manufacturing, and I'll get into why that is. Powder inventory management. As I mentioned, most that we deal with right now is aerospace type of additive manufacturing, so it's all a metal alloy powder. But the inventory management, whether you're using powder or some type of a polymer or some other material, have similarities. As you can imagine, when you're dealing with aerospace and even on the medical side, knowing what powder, how many times it's been used is important to know that and track that. And of course, the last thing is just having auditable documentation. That's critical. So the first thing on the AM requirements are basically the work orders. I'll talk about how they get generated, instructions, and how we track those things. And we came up with this idea of a sort of a build plate platform-centric work orders. I'll talk a little bit more in detail later on about that and show you an example of what that looks like. But this is one thing that was different that we found in the additive manufacturing environment for an MES system versus another type of a manufacturer. The various operational steps that are being tracked. So you have a work order. It's made up of what we usually refer to as a process, and a process is made up of individual steps or operational steps. and basically parts will need to get tracked through all of those steps, so you know where they are in the process basically of printing, and also as an auditability tool is to be able to know who touched what, when, where, what machine was it on, all of that. But part of that is the ability you need to have very verbose instructions available for the operator. You need to be able to attach any number of version-controlled documents. Now, this is not necessarily different than other manufacturers. You need to be able to connect and view these, what we call specifications, which could be operating instructions, SOPs, or quality management documents, directly from the production floor in a paperless manner, so that when an operator is referencing this type of information, they always have the latest version available, and basically guarantee that they're not going to be looking at some old revision of an operating instruction. And then we have something called specifications. It's a term I wish I could find a different term for it, but it's way broader than you may think when you hear of a specification. But part of what it can do for us is automatically qualify operators and equipment and vendors in real time to make sure and hopefully prevent any kind of improper processing of the parts. So if a operator has not been trained in that particular procedure, they're not, at least from a system standpoint, able to say, I'm starting work on this job and this particular operation. Likewise, if the piece of equipment that you're using, whatever it is, doesn't have to be a printer, it could be any piece of equipment, if it has to be at a certain level of maintenance or has some type of certifications associated with it, if it's not at that level, we can stop the operator from saying, I'm going to run it on this piece of equipment. And the same thing with vendors, outside vendors. So a lot of these parts get sent out to outside vendors for all sorts of different things, at least in the metal additive world. Heat treating is a normal first step, various types of heat treating right after they get cut off the plate. But you can be sending out to outside vendors for a lab for doing some measurements. So you got to be able to know, is that vendor qualified to do what you need it to do, and be able to track when we send it to them, when we get it back, so you can track how efficient they are. And the quality data that might be required, there could be in-process quality tests that need to be performed at specific operations. And there might be some additional data, that's quality data or processing information or any kind of really arbitrary data at any one of these operational steps. You need to be able to enforce that that data is collected and entered when it has to be. Not before, not afterwards, but at that specific point in time. And of course, that all helps on the quality side to prove that you've got control of your process. Serialization, I mentioned, big deal, aerospace, medical, and lots of other AM companies. So you want to be able to have guaranteed serial numbers, unique serial numbers. Found you need to be able to have different templates, so not just like generate a serial number. I've seen systems that do that, just some nonsensical number that comes up, but actually have user-defined templates of this is the specific format of this type of serial number, and be able to say, well, you want to exclude certain characters. We don't want capital O's. We don't want X's. We don't want I's or L's. So you avoid confusion with the serial numbers. But to be able to define the specific template, and then be able to have these templates that you have, any number of them, assignable to every part that you're going to be printing, because each part you may have a completely different serial number template you want to follow. Serialization also comes down to, at least how we've ended up using it, down to the build plate or the platform. And basically be able to generate a unique serial number for that build plate. And it's a way we can use, and you'll see in just a minute here or so, how we can connect all different work orders of all the different parts that might be printed on this build plate. At the same time, how to connect them all together, but make them have unique routes. And of course, you need to have a build plate template. It will set up that because you may have different types of templates for different types of builds. And when you actually track the physical build plate or platform, or however you refer to that, if you want to track that, it can be tracked as equipment being used for that operational step, or as an inventory item. It's like a bill of material. So when it comes down to this build plate or platform-centric work orders, what it turns out is that there are basically two types of tracking configurations we've run into. And one is the simplest. Say you're printing one part. That's it. That's on that platform. That part, the building of that part, and removal of that part, and the subsequent operations, whether they're inspections or other types of outside vendors, that part basically has one route from build all the way to shipping. So in that case, you could just do that all with one work order. Or if you had multiple parts that you were, say, the same part on that build plate, and they were all going to follow the same route, they were all going to stay together during the processing, you just need one work order. And at that point, you could put a serial number on this work order for basically the build plate, but it's not required. Now, the second one we found is pretty common, is that they're not just one part being built or many of the same part. They're all in one route. It's many different parts, completely different parts, different test coupons and test bars that are printed at the same time. And all of those parts could go down multiple different routes. So during the printing process, they're all together. And then once they get removed from that build plate, then they could potentially go down different routes. Well, if they go down different routes, then this is where this build plate centric work order came from. So if we have a build ID, basically, that we assign, we can have a work order. The first work order would be the build work order, which is stepping through all of the steps you need to track to build those parts onto that platform or that plate. And then at the point where they get removed, then you can have multiple, as many as you need, other work orders for each of those parts that go in different routes. They start getting tracked on those other work orders, on their individual work orders for their different routes after they get removed. So test bars are going to go one way, coupons go another way, the parts go a third way. If you have different parts, they could go any number of ways. So putting this build ID allows us to knit all of those together so that we know that all of these other part work orders for the post-processing, they were all built together on this particular build work. And let me show you what that looks like. Just an example here. Now, what we have here is we make a designation of this is a build type of work order. So if you print it out, this is going to follow the parts out on the floor. And the build work order has other information here, but you have a build ID. And then the key points here are basically all of the parts that are associated with this build platform. So we have basically a fictitious build part here used for tracking. But then there are three other work orders, 2209, 2219, 2220 here, with three different types of parts. And we have the quantities here. So we can, at a high level, you can see out on the floor, these are the various operations we're going to be running through during the building of these parts. And this date is filled in automatically. If you reprint this mid-process, it'll show the date that these various operations were completed, started and completed. And then all of the serial numbers that are involved. So you can see we have a serial number for our build plate, or basically build ID, that's linking all these together. And then we've got separate type of part number, a type of template being used here for these different parts. And then down here, showing we've got the two other work orders, one for coupons and one's for test bars, and they have their own serial number formats. So that's the build work order, and then each of the other work orders come along with this. So this is one of the parts, and so this is this sample AM part, and these are all the operational steps that this part's going to flow through after it gets removed off of the build plate. And you can see dates here when things are completed. And here are all the parts, numbers. It's all the same part, and they all have their own serial number. And then the last one, there are a couple more here. This one's for the coupons, and the coupons go through this particular process of post-processing after they get removed. And they have their own serial numbers. And then the last one here is for the test bars and the operations that they go through, and the different parts that were here in the serial numbers. So you can see what this could look like out on the floor and how these all get knitted together. And then, as you can imagine, we had to come up with this idea of a package, a work order package. And if you are building, if you're in a situation where you're putting multiple parts on the build plate and you're printing all those and they all have different routes, we've seen, at this point, we've seen one setup where there are 20 different work orders associated with it. So there's a build platform and 19 other work orders for all the different parts and coupons and test bars. And you can certainly enter all those in individually and tie them together. But if it's a package that you're going to be printing over and over again in the future, the ability to save that, so you know that these are the 20 work orders. When we run this package of parts, it's 20 work orders. This is the serial number templates we need. These are the specific parts that have to be on specific separate work orders. Here are the processes. Here are the quality control information that goes with them. Here are all the latest specifications and instructions. So you can assign this package so that when you're going to run these parts in the future, just pick that package and those 20 work orders just get generated and away you go. The nice part, it's not copying the old work orders. It's just making a reference of which parts were there so that we make sure we pick up all the latest information. So if there have been changes to your SOP or your QMS documents or the operating instructions for this particular step or quality control plan has changed, all that new stuff, current revision stuff is pulled into the new generation of those work orders. So that was something we hadn't really seen before. It makes sense in an AM world. Of course, we have all these serial numbers now, and we have got to track all these things in a detailed manner throughout the entire process from building to shipping. So here are the realities that we found on the shop floor for tracking. Now, the first couple are standard MES type of functionality, right? You've got a series of operational steps that parts flow through. They have to be done in sequence. It can't be done out of sequence. You can't do step 5 until step 4 is completed. That's how normal MES stuff works. Of course, you can throw in there, these are optional steps that may or may not happen. We may do them for some and not for others. That's sort of standard, still in the standard realm of MES type of functionality. The next two we found were a little bit different, particularly the next one, out of sequence, which is completely contrary to what you would normally set up a process. You want it to be sequential, not out of sequence. But there was some rationale for this. And the best example of why you'd want to do this. So you have a series of operational steps that you would normally perform in sequence, but you get to a grouping of them. And these are, say, all inspections that are happening, post-processing inspections. and maybe 3 different ones. And you get to the first inspection step, and that particular piece of equipment you want to use for that inspection is being used. Someone else is using it. So you'd say, okay, well, we don't need to do these inspections in order, so I'm going to go to the next one or the third one. So basically you can, within that group of out of sequence, you can pick any sequence you want, but all of those items have to be completed before you can move on beyond that grouping. So they gave flexibility. We hadn't run into that in the past in standard manufacturing. So that was a unique thing. And then multiple possible routes. And basically the best example for this is during the sequence of all these operations, you get to a point for, say, heat treating. So the parts, these metal parts get cut off the platform. They've got to go to some heat treating. Well, at that point, some companies have their own internal heat treating departments. Some people don't. And they have to send them to an outside vendor. But the companies that do have their own internal, they can make a decision at that point. Can we run these parts in our heat treating department? Do we have the capacity for it right now? Yes, okay, we're going to go that route. Nope, they're tied up right now for the next 2 days. We're going to send them to an outside vendor. So that'd be another possible route. So that's where you kind of pick in real time when you get to that point, how are we going to heat treat these, or how are we going to whatever multiple route processes, and you pick, we're going this direction, A direction, or B direction. So that was something unique also. You put all that kind of stuff together, it just creates havoc with a tracking system in MES, but it is possible to get that all functioning. And of course, outside vendors I mentioned, we got to be able to manage those too, and track within the entire process of the parts. When do they go out to the vendor? What vendor? How long did it take? Vendor travel or another documentation needs to go out with the parts. And maybe they have to get sent to another. They're going to 2 outside vendors. So that first one's got to ship the parts when they're done to another vendor, and then finally they come back to your organization. So that was something we need to be able to do. And of course, tracking the machine time and as well as direct labor time. So that's kind of given here. We want to know how much time is being used on these printers and how much labor is involved with all of that. So you can get a better handle on pricing. Non-conformances. Yeah, this was interesting. Now, everybody's got non-conformances, but what we found out in the additive world, particularly if you're talking R&D, but it's not exclusive to R&D environments, but non-conformances are the norm. They're not the exception. Everywhere else we've worked, it's an exception to have a non-conformance. Here, non-conformance is all over the place for all sorts of reasons. So that was kind of an eye-opener for us. And along with these non-conformances, all of a sudden there's more advanced dispositioning requirements. And again, you're thinking NADCAP and aerospace, you can understand why you want to have real detailed dispositioning. So we got all these serial numbers being printed, and we need to know that specifically which serial numbers are involved for any given nonconformance. And then to be able to disposition it, sort of a simple disposition, the entire nonconformance and all the parts and serial numbers related to it, it dispositioned once basically as a whole, or getting down into the disposition of individual serial numbers. So you could have 5 serial numbers that were part of the nonconformance. They were as a build stop or a couple build stops, and they were infected, but you can't really tell if it's going to be an issue or not. So you finish the build, and these 5, you want to be able to take a look at them and do some further inspection afterwards, after you cut them off. And then they may be dispositioned completely differently. You could look at one and say, it's scrap, no help in it. These 2, they look okay, so we can continue to process those. This other one, we're going to have to run it through a rework order or a series of rework orders to see if we can fix it. And then eventually it's got to get dispositioned effectively. Either it's going to be usable or it's going to be scrap. So advanced dispositioning, critical. And the other thing we found was interesting is that you get not just nonconformance for a serial number, but you could get multiple nonconformances for the exact same serial number on the exact same operational step for completely different reasons. And then to be able to track and disposition all of that stuff. So that was an eye opener. And deferred dispositions. This was another interesting thing that we found in the AM world. Is as I mentioned, you might have a build stop or a couple of them, and that's going to generate a nonconformance, and then you're going to have to disposition it. And the disposition might be, we're going to kick the can down the road a bit. We can't really tell at this point, so we're going to take this disposition and we're going to set it up at a later operational step to make sure that those serial numbers get stopped at that point, and whatever issue we found here gets addressed in disposition at that point. So you can move it to, basically, we'll consider moving this nonconformance to a later operation on that same work order, or if that nonconformance was during the build process, you may have a whole bunch of other part work orders where you want this nonconformance moved to, so that at the same operational step or different operational steps on different work orders, that nonconformance is going to show up to make sure that those serial numbers get stopped at that point and the nonconformance gets addressed and dispositioned properly. So that was another unique thing. And I know I'm running here a tad long. Are we okay, Jason? I'll assume that's yes.
Yeah, we're good.
Okay, good. Powder inventory management. Again, this is metal alloy powder I'm talking about, but if you're printing with other substrates, you can have the same type of concerns here. BOM for the powder or the material that's going to be connected to a part. You want to be able to assign that ahead of time. This is the powder type that we're going to be using on this part every time we build it. And then knowing how many times use powder is critical. Again, I'm going to go back to the aerospace side. If I'm flying in a plane, I would like to know that the parts that were built, and we're all flying in planes now where parts are being built in an additive world. I want to make sure that those are all virgin powder, that if not, it can't be contaminated with anything else, that we're using the best powder possible to produce the best parts. Depending on what's being printed, there may be a requirement for just virgin powder. When I say that, it just means it's right out of the box from the manufacturer right into the printing hopper. It hasn't gone anywhere else, right there. And quite often they'll put a series of pounds or kilograms in, and whatever is required to print those parts, and there's some left over. It depends on what your policy is. Is it tossed? Is that filtered out and put in a box, and now it's going to be considered a one-time use powder? And maybe some parts that you're doing, or you do some test stuff or R&D, perfectly fine to do one time. But if you use a one-time and there's remaining powder, now that's got to be considered a two-time use powder as soon as you do that. And if you combine lots, which happens, particularly, again, in R&D, it's not as important. You're just doing some test stuff, trying to get the geometry right so to build it. These aren't going to be usable parts. If you combine stuff, like if you use a one-time and a two-time use powder and put them together in a hopper, that's going to be a two-time use powder. Or if you add virgin and put a three-time use, it's going to be considered a three-time use powder. It has to be. So be able to know that and track that is important. So this historical lineage of this powder becomes important to be able to see what type of powder was used, how many times it was used in the past, and be able to say for this particular powder, which specific orders and parts were produced from it, and if it was a three-time use powder, which parts were produced when it was three times, which parts were produced when it was two times, when it was one time, and when it was virgin, and if it was a combined lot, then to be able to have this lineage all the way back where you could see exactly all the different lots all the way back to their virgin origins to know exactly what parts and people touched it and printers were used and parts generated. That becomes a big deal. That's kind of a hard thing to do. So a lot of companies are still just kind of getting basic tracking of powder lots at this point. And of course, all this stuff going on, all this data getting generated and tracking and serial numbers, you want to have some complete documentation of all of those changes. And to be able to have all those documents and records linked together so that when you get to an audit, that makes the audits more stress-free, not stress-free, but less stressful. It makes auditors very happy. What we see almost all the time is auditors, when they come in with a company that's been using Blue Street Bright AM, and that their audits take half the time at least. So if they were scheduled for a 4-day audit, often they're out of there in 2 days. And what happens is that the auditors are really happy about this. It gets them out of your location, but they get all the data they need. It's just a click away. And then you may say that, well, it's not going to save you any money on the audit. They're going to charge you for that audit, whether they're there for 2 or 4 days, the same amount. And I'd say yes, but they're out of your hair quicker, and that's a big deal. So you can get back to managing your business and getting the quality parts through, and not worrying about digging out paperwork that might be in some off-site location storage. And we're actually getting auditors recommending us to companies they run into, just because they say, hey, this is such a nice system. This is what you ought to be using. So that's really helpful. We enjoy that. And of course, when you have kind of all this data all connected up and linked together, it gives you an environment that's much easier to have some continuous quality improvement initiatives going on. And of course, that also allows you, if you're producing quality parts, and makes your customers happy and confident and satisfied with you. And they're not going to look somewhere else. They have their parts built. So that's basically it at this point. I'm a little over here. If there are any questions, if we're over time, that's fine. If there are anything, I'm happy to entertain those.
No, thank you, Todd. We're good on time.
Okay.
We'll now head into the Q&A session. Like Todd said, if anyone has a question, please, and if you haven't done so, type it into the chat box. And I have a few questions here we can start out with. The first question asked was, is it possible to run a manufacturing production facility paperless?
Well, that's the easy answer would be yes, but it's yes and no. Okay, so there has to be some paper involved at some point. At a minimum, you have to identify those parts out on the floor, everywhere they are. So I would say not completely paperless, but almost paperless. So if you're dealing with issues like ITAR, which is if you're doing military parts or any type of firearms, there's a requirement in ITAR that only U.S. citizens can have access to the various data. So what I see, so what happens is that if you've got some people that are not fully U.S. citizens, they have green cards, they're perfectly fine to work your facility, but they can't see specific data for specific orders if it's an ITAR type of order. Or if you've got guests coming through your facility, you got to make sure that all that kind of critical information is not viewable by somebody. So what I see often out on the floor is that places that are very heavily paper-oriented out on the floor, what they'll do is they actually flip the work order upside down, so you have a blank piece of paper there. And that's what they end up doing, which is kind of interesting. That's the solution to it, but it's really not. You have a wind blow through, and poof, that paper goes somewhere else. So you need something out to identify the parts. And if you do have workers that are restricted from seeing specific work orders because it's ITAR, then having just enough information to identify this is the work order, customer, and maybe part information that's not critical. But everything else, you drive them to the system online to get all the other information, all of the operating instructions, all the quality data, everything they need to see, they can see online, and you can make sure that that person who's viewing it, then is logged in and viewing it, has that what we call a specification that would allow them to view the ITAR information. And other people who tried to wouldn't be able to even get access to those orders. So completely paperless, not really. Minor paper, yes.
All right, thanks, Todd. We have another question here. So can you describe how we would manage our parts that go out to a post-process vendor for additional work, such as heat treating?
Yeah, basically that's going to be, would be handled as an operation. Let me bring up this. This would be a good example here. So this is a test bar, which is it's a part. And it's going to go through some non-destructive testing and some heat treating operations right here. So an outside vendor should just be set up as an operational step on the work order, and therefore you can track it. So anything that's a step you can track. You know who touched it, who started working on it, when they started working on it, when they were completed with it. So an outside vendor would be set up as an operational step like this, and then as part of that, that operational step, you should be able to identify who the vendor is, and then be able to produce the paperwork that you need to go along with those parts outside of that vendor. Typically, is referred to as a vendor traveler for us, but and so that's how you track them. You basically say, we're starting this operation. The vendor traveler is generated with all the information they need. That paperwork can go out to the outside vendor, and then when they return back, then you complete that operation, and then parts can flow on to the next. So that's using paper. It is possible, obviously, in today's technology, where you can have that be more system-to-system communication and not have to produce paperwork. With full instructions that go with the parts. You could have Blue Streak, Bright AM talk to the outside vendor's ERP system, and then back and forth to transfer data. So that's another way, but that's how you generally handle outside vendors.
All right, thanks. One more question here. You mentioned that you need to have flexibility to track the real-time splitting and combining of parts within the various operation steps. Can you give an example of this to help with better understanding?
Sometimes operation steps, parts don't necessarily all go through the same operation step at the same time. Heat treating, again, could be a good example of that, where it's a batch-oriented type of an operation, and there may be limits to what can go inside of that furnace or that oven. And so it could be size related or weight related or some other reason, baskets or something, but they may not be able to get all the parts processed or heat treated, say, at an operation at one time. So in that case, the parts basically have to split apart. I don't mean the physical split apart. I mean the various serial numbers you have. If you have 10 parts, serial numbers 1 through 5 might be able to go into the operation and be completed, say, a heat treating operation. And the other 5 serial numbers are still at the previous operation. And it could be that if for there's a reason for it. Those other 5 parts, those first 5 parts could continue to flow through the subsequent operations, and then the 5 that are sitting back at another operation can get moved in this heat treating step when it's available, and then they can get moved through. Or the other ones, the first ones that came through could just be sitting at the next operation post heat treating, and then the other ones join up again with them, and then therefore they all can be tracked in a group again. So it's that's a reality out on the floor for all sorts of different businesses, and so to be able to split them up, have them track individually, and then combine them up again in future operations is something that's really needed.
Okay, and we have another question here. What type of heat treatment is used?
Oh boy, oh, there's all sorts of. The couple here is I think the HIP is a heat treating process where the parts are put in to a heat treating vessel that can have basically extreme pressure put into it. And that's basically to kind of squeeze the parts together, to take all of the individual metal pieces that were melted and get rid of the area, get rid of the area, the void between them. So actually parts will, I'm not talking, this is not huge difference, but parts will actually change their dimension, their whole geometry after being hipped. And because it will squeeze into different sections. And the next one's probably a solution heat treat or a heat treating to just kind of relieve stress on the parts. There's still stress involved with when you're doing metal type of additive manufacturing. So.
All right, thank you. We got one more here. As examples, what kind of technology have you seen being used on printing serial numbers, on printing parts?
Well, let's see, I'm not quite sure that the technology, the serial numbers are usually incorporated into the, I'll just say at sort of a high level, the CAD drawing, the CAD, 3D CAD representation of what's being printed. So if you have 10 parts on there and they all have serial numbers, or if you have one part, doesn't matter. The serial number is basically put into that file and then sent to the printer, so that the serial number, the unique serial number for every part, is put into the file being sent to the printer for printing. So I think that's, and how that's done, I mean, it gets printed along with the other parts, one layer at a time with whatever medium you're using. But there's specific programs out there. Materialize is one that we're familiar with that can automate that. So Bluestreak can generate the serial numbers, the unique serial numbers required, and Materialize knows the geometry of the whole build plate and all the parts involved, and knows where the serial number should be placed on all the parts. And then it can basically assemble that, redo that file, and with all the serial numbers, and then send it off to the printer and monitor it. Hopefully that answered.
Okay, great. All right, great. I think that's all of our questions. So that will wrap up today's TRX webinar series. I would like to thank our presenter, Todd Wenzel. If you have further questions for Todd, please reach out to him directly at the, did you have your, it's at todd.wenzel@bright-am.com. There will be a post-webinar survey going out to all those who participated. We do really appreciate the time you take to provide American Makes feedback, so we may continue to improve and strengthen the additive community. And a reminder that if you think you or your organization would be interested in sharing on the TRX webinar series, please fill out the form that follows the presentation or reach out to Tiffany Westbay. Thank you very much.